Hi kids, are you ready to rat-a-task? Okay, let's get started. This week's experiment is slippery or not slippery. So grab your activity notebook and let's get started. Okay, so grab a pen or a pencil and let's turn the page and get started. And we're gonna set up our experiment. Let's make sure we have everything we need to do the experiment. So in your little packet, you should have a tube of soap. Check. A tube of citric acid. Check. A tube of freeze-dried coffee. Check. A tube of distilled water. Check. A tube of sodium bicarbonate. Check. A bottle of distilled water. Check. A set of stickers. Check. A little packet of litmus paper. Check. A transfer pipette. Check. And finally, the safety glasses. Check. Okay, so now that we know we're ready to go, let's move on to using tools and chemicals like a chemist. So we're going to ask questions because questions are the best way to learn. The first question says, what is soap? Soap is a large molecule made of many carbon, hydrogen, and oxygen atoms. Soap is able to mix with both water and oil. This makes soap good for cleaning. The next question says, what is distilled water? Distilled water is water that has been purified by a process called distillation. Distillation is a chemistry technique that begins when water or another liquid is boiled. Boiling causes some of the water to turn to a gas called water vapor. The water vapor goes into the air, leaving any impurities behind. In distillation, the water vapor in the air is collected and allowed to cool back to pure liquid water. So it's very purified water. The next question is, what is litmus paper? Litmus paper is a special type of paper that turns blue in liquids that are bases and pink in liquids that are acids. Litmus paper can be blue, purple, or pink before it changes color. All right, so turn the page and go ahead and see if you can answer the questions for this review. All right, now that you've reviewed some questions, let's go ahead and practice making your own questions about acids and bases. So, questions are the best way to learn. And sometimes getting a question started can be challenging, so here's some help getting your question started. You can use any one of these phrases. What will happen if? Can I? Is? Will this? How much? Does? When I? Or why? So in the space below, try writing some of your own questions. And I'm going to write my own question as well. Okay, so when you're finished asking your questions, let's turn to the next section. This is where we get to do the experiment. It's the test, tinker, try. All right, so the question asks us, do you think there are ways to tell the difference between an acid and a base? So let's try this experiment to find out. First, we're going to test it. The first instruction is to find the following pages labeled slippery and not slippery, and remove them from the book and place them on the table. So let's go ahead and do that. We've got a page here that says slippery. I'm going to just tear it out of the activity notebook and put it on the table, and then grab the not slippery page, fold it a little bit, make it easier, and rip it out of the activity notebook and place it on the table. Next, gather the 5 test tubes we just pulled out of the bag And this is optional, but you can grab your tube rack if you have it handy and stick them in there, but you don't have to do this. And I'm going to stick them in the tube rack. The soap one doesn't quite fit, but I can get it in there a little bit. Next, one at a time, remove the screw cap from a test tube and use the transfer pipette to add 15 ml of distilled water from the bottle. So we're going to go ahead and remove the screw cap. And we're going to add some water to the test tube. And you can use the transfer pipette. And you can fill it up. Okay, so now we're going to fill the test tube up. And remember from the very first lesson that there's a little line at the top of this test tube, and that tells you when there are 15 ml in the tube. One of the tricks that chemists use that you can try is to only fill it up about halfway. This is optional, you don't have to do it this way, but this is the way I like to do it. Go ahead and fill it up halfway, and then put the cap on, and then give it a nice quick little mix. That way you get some of it mixed in, and it's not over full to dissolve the citric acid. Then once it's pretty mixed in, you can continue adding the distilled water until it reaches that 15 milliliter mark. Okay, now that you've got 15 milliliters in there, put the screw cap back on and go ahead and get it all good and mixed up. All right. So do the same thing for the rest of them. The freeze-dried coffee, the sodium bicarbonate, and the dish soap. Go ahead and add 15 ml to each of these. If you want to speed this up, you can pour some of the water into a beaker and then very carefully pour the water into your tube. Again, filling it about halfway, mixing. Mixing it up a little bit, and it's okay if not everything dissolves. Get enough of it dissolved, then fill the remaining with the water in the beaker. And when you get close to the top, you can use the transfer pipette like we did in the first experiment to just get it as close as you can to the top line. And there we go. Okay, so now that we're at the dish soap, notice that the dish soap tube is a little bit different size, but it still will hold 15 milliliters of water. All you have to do is just again put the water up to the top. You can fill it halfway, mix a little bit. And fill it a little bit more. Using your pipette tip, go ahead and top it off. And it's okay if it's a little bit bubbly. That's what soap does. Mix it. And okay, now we're ready for the next step. So next, we're going to dip our fingers into each test tube, or you can pour a little bit of the liquid in your hand. And then we're going to decide if the liquid feels slippery or not slippery. Now, most of the time in chemistry experiments, you don't want to put things on your hands and you don't want to put things in your mouth. For this experiment, the instructions say we can put these on our fingers, and that only means that everything that we're using here is safe. So go ahead and dip a little on your fingers, and then what I like to do is you can tip the tube a little bit on your finger and just move it around your fingers and just see if you can feel if it's slippery or not slippery. Does it feel slippery in your hands or not so slippery? And then when you decide whether it's slippery or not slippery, put the cap back on, and then you're going to grab a sticker. So that was citric acid, and we're going to grab a sticker, and you place the sticker on the paper that says either not slippery or slippery, depending on what you got. So citric acid wasn't very slippery to me, so I'm going to put this one on the not slippery page. So do all the rest of them, pour them into your hands. You can use a towelette or something to wipe your hands in between, clean off your fingers, and then just decide if each one is slippery or not slippery. Okay, so now that you've tested all of the tubes with your fingers and decided whether they feel slippery or not slippery, let's go on to the next step. The next step says, what did you discover? In this chart that you see, go ahead and record your results. So what I got, soapy water was slippery. Citric acid water was not slippery. Coffee, not slippery. Distilled water is not slippery. And sodium bicarbonate water was slippery. So you can just put an X, whether it was slippery or not slippery. All right, so now we're going to test this with a technique or a tool. We're going to use the litmus paper to scientifically decide whether or not this is an acid or a base. So remember from your reader, acids tend to be not slippery and bases tend to be slippery. And so we did check it with our fingers to see whether they were slippery or not slippery. But we can actually use litmus paper, which is an indicator paper, to test whether or not these liquids are acids or bases. Okay, so now that you've opened your litmus paper bag, you can gently pull the litmus papers out. You should have about 8 of them. And you can spread them out on the lower part of the paper or you put them in the notebook. You're just going to want to pick up one at a time. And holding the end of the litmus paper, grab one of the liquids, one of the test tubes, grab one of the test tubes, open up the cap, and then just dip it in there. And see if you can see what color it is. So this is citric acid. I'm going to lay it down next to the citric acid label. And go ahead and repeat for all of the tubes. So now that you've tested all of the liquids with the litmus paper, we're going to record those in the following chart. So go ahead and turn the page and looking at your little pieces of litmus paper. Soapy water was pink. Let me get back to that in a minute. Citric acid water is pink. Coffee is pink. Distilled water actually didn't change any color at all. It stayed pretty neutral, so I'm going to say no change. And sodium bicarbonate water definitely turned blue. So this is what we got out of testing our liquids with the litmus paper. And remember, from our description of litmus paper, let's go back and read what litmus paper does. Litmus paper is a special type of paper that turns blue in liquids that are bases and pink in liquids that are acids. So let's think about that. So citric acid turned pink, and we can mark what we see here. Citric acid turned pink. The water was not slippery. Yes, that was true. The sodium bicarbonate water was slippery and turned litmus paper blue. Yes, that was true. Distilled water was not slippery and did not change the color of the litmus paper. And that's also true. But I want to point out something that's interesting in this experiment that I actually didn't expect. It's a surprise to me. And that is the dish soap. So if you look over here at our result with the slippery, remember that slippery liquids tend to be bases. But dish soap in this case turned pink. Right? So notice that dish soap is slippery. So I didn't put it over here in the not slippery side because it's actually slippery. But it looks to me that it also turned the litmus paper pink, which indicates it's an acid, which is not what I expected. Dish soap is generally basic. In other words, it generally turns the litmus paper blue. So one of the things I want you guys to notice here is that the dish soap that I used was orange. Well, we have another kind of dish soap here that's blue. So what do you say we test this blue dish soap and see if it's different than this orange dish soap? I'm going to go ahead and add some water to this blue dish soap and see if we get a different result. So I'm going to go ahead and test it with my fingers, just to repeat the experiment exactly. Yes, indeed, it's very slippery. So what do you think? Do you think it will turn the litmus paper blue, or do you think it will turn the litmus paper pink? Let's give it a try. Aha! This soap acts like regular soap and turns the litmus paper blue. This soap is different than this soap. I wonder what's going on. So let's rat-a-taz this. Let's find out why these soaps are different. Let's investigate it. The first thing we can do is just find out what's on the bottle. This is the orange soap, and if I read the bottle, I find out that this particular soap has a number of different ingredients, and the active ingredient is something called lactic acid. 2% lactic acid. Well, lactic acid is an acid, and that's why it turns the litmus paper pink. It's got enough acid in it to turn the litmus paper pink. If we think about the other soap is just ordinary soap. It's not an antibacterial soap, so it doesn't have any lactic acid in it. And so we rat-a-tazzed it. We asked some questions, we did a little bit of reading, and we answered those questions. And we tested and tinkered and tried and played with the different soaps. So next, go ahead and ask some of your own questions. Remember, you can start your question with any one of these prompts. How, why, where, is, does, can, when, or what. When you have your question, think about what your favorite question is and circle it. So I'm going to write my questions down. So the next step is to go ahead and play with your questions. So circle your favorite question and then try to figure out if you can answer it. Maybe you can design an experiment, or go on a field trip, or call a scientist, or do just a Google search. And finally, when you get a chance to answer your question, talk, tell, and dazzle. Share what you discover. Some ideas for sharing include making a video, or a drawing, or taking a photograph, or writing a report, or giving a lecture. So once you answer your question, share it with somebody and tell them what you discovered. And we'd like to hear from you, so share it on social media, #rat-a-tazzle. Hey, thanks for rat-a-tazzing with me. Join me in the next video when we break the box. See you next time.